One of the toughest aspects of object-oriented thinking is knowing when you have an object or not. And it's even more complicated because something that might be an object in one system or one part of the system might be trivial in another part, or might be many objects in another part. So I don't want to give you an answer. And there's no rules to say what an object is or isn't. And two people might perfectly create perfectly good objects for the same system in very different ways. So instead, I want to talk about the idea of a mantra for identifying objects. Comes from a good mentor of mine, Dr. Frank Sternberg, and so this is his idea that I want to pass along to you. But let's start with the idea of what's different about an object versus just everyday variables. So most variables are there as little storage depots for values, right? So I have an integer, I have a string, I have a date, I have whatever variable types you have, but they tend to be isolated and individual. They tend to not be grouped in any sort of meaningful way. Now, many languages have mechanisms, records, or other ways of naming them, to be able to group things together. We're not talking about arrays or lists here, which certainly they can be, but just the idea of having disparate variables that describe something in more detail. And that's exactly what an object is. But an object is more than that as well. You see, objects don't just know things. They don't just collect a bunch of data, date of birth, first name, last name, height, weight, all the things you can use to describe a person. But they also do things and they communicate with other objects. So the idea behind object orientation is not simply to group data in a meaningful package, but group data and functionality in a way that creates a useful thing for the world. Remember, like real world things. Your car, for example, is a bunch of data items. It has a color, it has a speed, the amount of fuel that's in the gas tank. It has, the number of seats available for people. The number of miles it's driven. All sorts of data. But more importantly, the car does things for you. It takes you places. It transports things. It locks. It has air conditioning. And even has the ability to communicate with other objects in some way, sometimes negative ways. You can crash into things, but you can make phone calls from modern cars by connecting through. That's, I mean, a very surface example. We'll get into more of what that means in software as we go. So again, the core of an object is what it knows. Grouping otherwise unrelated seemingly variables into an important concept. So as we look here at this game of checkers, we can create something called a game board. That's a real world object that's out there. We can create pieces. There's another real world objects out there. And so the game board itself can do more than just simply be the board. We can actually imbue the game board with some intelligence. It has the board itself, which could be, an array or a multi-dimensional array of things. If you're talking about a checkered board, it's really simple. There's either a piece there or it's not, and the piece is either, in this case, the darker color or the lighter color. Um, but then I can also keep track of things like whose turn is it? What was the last? Who made the last move? What was the sequence of moves that happened? You can undo moves and roll back the game. So the attributes describe this information that this board now knows about, that it keeps track of for me. And that enables us to do things like make a move. So what objects do is they use the data they have, the information they have, to make intelligence actions. It's not up to, in this case, the player to know everything. So think of it this way. If you were learning a new game, maybe checkers the first time or chess, it's a lot to remember if you just have, a piece of wood and some little round markers. But when you have a smart object like a computer game, it will ensure that your moves are legal, that you don't move pieces in a way that's not allowed by the game. It'll allow you to, as I said, roll back, or have computer players out there. And so these methods, operations, we'll see, are different ways of looking at it, are the behaviors that make our objects intelligent based off the information that we've given them that they already know. And the idea of communicating with other objects is really simply the notion of objects need a network to be able to provide useful features. So the game board obviously has an interaction with a player, or more specifically, two players in this case. The player who's playing the darker pieces and the lighter pieces, or however they're going to be red or black in some chess in checkers games. And those players make moves on the game board. They tell the game board what to do, and by basically interacting with the pieces as well. So a move on the game board might be an interaction between the player object, the piece object, and the game board object. There could be many objects involved, and so this interaction and keeping track of it's important because as a player, I could try and sneak forward. Like if I'm playing checkers, and in this case, I could take an extra stone and try and set it down. Well, the game board, being intelligent, can say, "Wait, I don't know this piece. Where does this piece come from?" or something like that. It's not about cheating in this case. It's about helping the programmer make programs that are less likely to have errors. So let me give you a more practical example here. So a real world thing, a product. We see some batteries here, and this product has some information about it. There's the name of the product, there's a description, 9-volt batteries, 4-pack, and there's a price. We can see the tag on it. All of those things can go into our virtual product. Now, what does this project do? Well, we'll come back to that. We're going to come back to that in a second. And the communicate, well, not every object necessarily communicate with other objects. There are simple objects out there that are just there to store information and provide us that information. That's mostly what this does, is it gives us access to the name, the description, the price. But these simple objects help us manage more complex objects, more involved objects. So for example, another real world thing we could see from a typical transaction is a receipt. And so on the receipt, we can things like, well, there's the date and time the transaction happened, and then there's the salesperson here, Donald B, who sold the thing. I assume that's what that one means. In this case, this is a restaurant. The number of guests, the table they were at, all sorts of data. Who bought this stuff? Not to mention the fact of all the stuff that they bought that's here on the receipt. And we'll come back to that in 1 second. But what it does then, this smart object can do all sorts of stuff, like go through all these different options, and it can calculate the subtotal, and it can calculate the taxes, and it can calculate the final total that we're coming up with. But who does this object communicate? Well, you could say it's the product. Obviously, it knows about the mug big red and the wings and the water and the burger and all the different things it interacts with. But that's a little bit too simple because there's more information on here than just simply the product, the name of the product and the price. There's how many of them that was bought. See, most of these are one, but this water right there has three. So sometimes object orientation has us having conceptual objects that live in the middle of this. So maybe things that you don't necessarily see directly as an object of its own, but part of an object, something like a line item. So on the receipt, there's many, many, many line items here. And a line item is a concept of a receipt where it knows the product that was selected, the big red, the water, the burger, funnel cakes, so on and so forth. And it also knows how many of those that were purchased. So in this case, 3 waters is the only one that, shows this capability deeply. But it's important that it shows that capability deeply because the idea is the product is the product. You might buy 3 of them, you might be one of them, you might buy 1,000 of them, but somebody else might do something different. The product doesn't care about how many times it's being purchased. So we need this conceptual object known as a line item that lives on the receipt. Actually, a bunch of them live on the receipt that will help us do stuff. And then there's things that a line item does, like compute the subtotal. So 1 times 550, 3 times 0. Not very difficult math, but it could be. It could be some complex functionality. And this is the bridge to communicate with the other product. This communicates with the product object that it stores, and it gets the price from that product object or other things that we might know, shipping weight or things like that. So if we go and revisit this idea of the receipt, we actually might improve. Objects are not necessarily obvious the first time. Yes, the receipt out here describes the thing that happened, the transaction that happened, but what about before I purchase it? I don't start with a receipt. I start actually with an order. And the order then has the date, the time, the salesperson, the stuff that we have, but it also, and it does compute and the the tax and the total, but it also communicates with several line items, a bunch of them out there. And those line items are really, really important. That communicating with those line items are important because that's the real heart of this functionality. And notice we actually are sharing the work here. So the way a receipt calculates itself is to basically go to each line item and say, hey, you calculate yourself. I don't have to do that work all in one place. Each little step takes a piece of the work, which keeps my system simpler and makes it easier to manage and test. So we'll get into many, many examples of this as we go, but I want to remind you of this mantra, which is really, really important, that objects know things, they do things, and they communicate with other objects. They don't all have to do all three of these things, but too many objects that only know things or only do things and don't communicate with each other might be a sign that you're not necessarily thinking as deeply or need some more practice in how you're working on your objects. And we'll get plenty of that practice for now. But I hope this helps you understand the idea of what an object is. It's a helper that does more than just simply sit around, store data, or blindly does functionality. It uses data. It uses its relationships with other objects to be able to give you useful features and be able to track and provide that in the future.